Okay guys, so in this lecture what we're going to talk about is estimations. Your job, if you become a physicist or an engineer, you're going to be asked to do a ton of problem solving. Actually, for any engineer, there's a problem, someone's going to come to you and ask you to solve it, and that's your job. So in this class we're going to ask you to do a lot of detailed mathematics, get really precise answers, but sometimes just making an educated guess is really all you need to get really close to the answer. If you can just use your intuition and some of your mathematics, you should be good to go. And the key word there is educated. It's not just a guess like you're seeing down there with all those Skittles. What you want to think about is, how big is one Skittle? What is the volume of that jar? So if I can understand those things, maybe I can get a really accurate answer for how many Skittles are in the jar. One thing we definitely deal with a lot in this class is the orders of magnitude. The orders of magnitude will go from your base unit, which is 10 to the 0 or 1, whether it's gram, meter, could even be seconds for time, and we can go big or small. So you can go up into the kilo, which is the 1,000 range, mega for a million, giga for a billion, or what I'm saving this video on right now is a terabyte. So 10 to the 12th is my power for a terabyte. But we can also go smaller in terms of our measurements. We can go into the millimeter or the micrometer or the nanogram or picometer, whatever unit you want, and you can see how the orders of magnitude are going smaller, 10 to the minus 3 for milli, 10 to the minus 6, 10 to the minus 9. Or you can write out all those numbers, but I bet you'll forget a 0 here or there. So I recommend your answers, if you get them into that power form where it's 4.2 times 10 to the minus 7. Make sure you put 4.2 e minus 7 in WebAssign. One of the most famous people that was really good at doing these estimation type questions was Enrico Fermi. He's more famous for being a nuclear physicist and working on the first atomic bomb, but he was also able to use this technique to kind of find out answers to almost impossible questions. So some of the estimation questions here I'm going to show you will be examples of what we call Fermi questions, like this one from the text. This one is in your guide and notes. You can follow along with it as I do here, but they say, hey, what's the thickness of the rubber tread worn off your tires if you travel 1 kilometer, or in that case 0.6 miles. The book follows you right through that example. I kind of have my own example I want to show you right up here on a board. So I'll show you my example and attempt at this Fermi question. Okay, so for my Fermi question here, I know it's not the same exact one that you have there in the textbook, but again, these are estimation questions. I'm more interested in the process of how you solve it and how you can get your powers of 10 to help you out here. So in here, I'm assuming that 1 full inch of tread will disappear off your tires by the time you need new ones, about 40,000 miles. That is really annoying to me. Buying tires is one of my biggest pet peeves, so here's what I can think about every time I drive my car. I can think that 1 inch will be gone after 40,000 miles of driving. That gives me 0.0000025 inches of tread lost for every mile. That's a really small number, and again, I might lose a 0 there, so WebAssign is going to want you to put it in as 2.5 times 10 to the minus 5th inches per mile, or 2.5 e negative 5 when you're using WebAssign. But again, since I know my orders of magnitude, I could actually shift this decimal over one more place and write it as just 25 micro inches of tread lost every mile I drive. So that's what I can think about as I'm driving down the road, that I've just lost another 25 micro inches of tread off my tires. So I hope that helps you out. If you have any questions, please respond, whether remind or email, and I hope that I can answer them for you. Try the WebAssign questions, look at the guided notes and the guided example problems for some additional help.